Okay, hello. Today we're going to be talking about similar figures again. If you recall, a chapter or two ago, we talked about dilations, where you take a figure and you dial it proportionally bigger or smaller than the original one. And the thing is that maybe you would take each of the sides and times them by two, so it's twice as big. And maybe you would take each of the sides and you times them by a half and then make each side half as big. So you can dial a pre-image to make your image either bigger or smaller. Okay, and so you basically, to do that, all the angles have to be the same, corresponding angles have to be the same, but the sides are proportionally bigger or smaller than the original shape. And so, like, the way that we did this was we looked at our original shape, okay, the pre-image. We said, okay, well, if these are similar, okay, the corresponding sides will be proportional and the corresponding angles will be congruent. And so, well, what sides match? Well, you can kind of see on this one, like tell which ones go together. But in this first one, you can tell that this side right here, the x plus 3, should match. Notice it's by the angle that has a one stripe on it. That matches this one right here. Okay, so those would be not equal, they're not congruent, but they're going to be dilations of each other. They're going to be proportional. And then also the top of this figure, that's 3, should be similar to the 2. Okay, and so you could write a proportion to find, what is the measure of x? What's the value of x that makes these to be similar figures? And so we would write a ratio of 2 over 3, because 2 matches with 3, equals x plus 3 over 2x plus 2. Okay, and so how we solved that was we set the cross products equal to each other. Okay, and so we said 2 times 2x plus 2 should equal 3, and then x plus 3. And we distributed both sides. We got 4x plus 4 equals 3x plus 9. We solved it by subtracting to get the x's to the same side. Then we added, or we moved the numbers to the same side by minusing 4. Yeah, x equals 5. And so if x is 5, these two shapes will be similar to each other. Okay, they'll be dilations, they'll be proportional to each other. And so proportions is a skill we're going to be using this chapter, but this is a prior thing that we learned, and we're just going to reviewing it. The next thing is to find scale factor. Remember, you take, to be like, what did I times everybody by? That's what the scale factor is, and we call it K. And so the question is, how do you figure out what that is? Well, sometimes you can just tell. You're like, oh, I times everything. I doubled everything. I times it by 2. Sometimes, however, you're like, I can't quite tell. And so then you do the image over the pre-image. Do the corresponding sides. I mean, it doesn't make sense to match up things that are not proportional to each other. But if you do the image over the pre-image, so say it goes from here to here, you can see it's getting smaller, okay? And if this part matches with this, you could do 3 over 12, which reduces to 1/4. And that makes sense. It is a fourth the size of the original figure, okay? And then the next one, notice this is dilating it bigger, okay? And so if you want to figure out what is the scale factor, you could do the image over the pre-image. And so that would be, in this case, 24 over 8, which is going to be 3. And so that means probably all the sides will be tripled, okay? And the answer is, yeah, actually, that is what, if they are going to be similar figures, and they're just dilations of each other, you got to be consistent for all your sizes. And this one's more abstract. If you do the image over the pre-image, you could do 5K over K. The K's cancel out, you just get 5. And so, oh, actually, if the K's cancel out, I misread this. It's 5K over 5. The 5's cancel out, you just get K. Okay, so you're timesing it by just the letter K to get to that value. So that's a little bit more abstract, and we're not going to focus on that too much. That's a little bit weird. So now if you think about it, if you have similar figures, if you dial the shape bigger, well, then the perimeter will get bigger proportionally, because the perimeter will get bigger or smaller based on the size of the shape. Okay, and so, and it's directly related to that. And so, in that chapter, we talked about if you write the ratio of the sides, that equals the ratios of those perimeters. And so oftentimes this year we talked about if you do the small over the big and do those sides. Okay, so like if you call this one the small figure here, and this one the bigger figure on the right, well, pick two sides that you know them. Okay. So if this side is 8 and this side is 12, and those are corresponding sides, so you could do 8 goes with 12. You got a small shape over the big shape, and these are the sides. Well, then the perimeters will also follow the same thing. Okay. So the perimeter of the small one, you know this. We're not going to solve anything. We're just going to say, find the perimeter of this, add 8 plus 12 plus 6. And that perimeter is going to be 24. And if you add 12 plus 15, hang on one second. Okay, and so then the perimeter of the big one is 12 plus 15 plus 9. And if you add those up, you get 36. And you can tell that if you reduce 8 divided by 12, okay, and if I divide them both by 4, you're going to get 2 over 3. And if you divide this by 12, you're going to get 2/3. So they are directly related. If you've got two similar shapes, the ratio of the sides is equal to the ratio of the corresponding perimeters. Because if you dial a shape bigger, the perimeter will grow at the same rate. So what we used in that chapter was to say, look at these shapes here. Okay, I'm going to zoom in so you guys can see this a little better. So if you're like, okay, if these are similar figures, they don't really look like similar figures, so you got to read the similarity statement. And so we know AB, and AB looks like it corresponds with DF. Okay, so DF, this one right here. Perhaps that looks like it makes sense. So if you write the ratio of the corresponding sides, and I'm going to do the big over the small. And as long as you're consistent, it doesn't matter. I'm going to do 12 over 8, and these are the sides. And we can add up and find the perimeter of this one. So if you add up 6 plus 6.8 plus 8, you're going to get this perimeter to equal 20.8. Okay, and so the smaller perimeter is 20.8. Well, since they're similar figures, their perimeters will be proportional as well. So if you dial down the sides, the perimeter will shrink. And so we can write down what would be the perimeter of the bigger figure. And because they're similar, the perimeters will be proportional. So let's cross multiply and find this. So we're going to do 8x is equal to 12 times 20.8. So if we do 12 times 20.8 equals, we get 249.6 equals 8x, divide by 8. So that means that x is equal to 31.2. That means the perimeter of this larger figure is going to be 31.2, and that'd be units. So you can write a proportion because if the sides are proportional, their perimeters will also be proportional to each other as well. All right, if you were in my class, I would be like, no, try this one, see if you can find the answer to that. Now, let me see if I can get this to zoom in. All right, here we go. Okay, so it gives us a similarity statement so you can tell who goes with whom. So we got EF here. So EF is this guy, and that would be BC. Okay, so those two sides are going to be proportional. So you could do 4 over 6. It'd be small and big. Equals, and then we need the perimeters of each. Okay, so it says find the perimeter of both figures. So the perimeter of this one, you can just get by adding 6 plus 4 plus 3. Okay, so 6 plus 4 plus 3 is 13. And the perimeter of this one, we don't know. Okay, and so the smallest perimeter is 13. We don't know the big perimeter, but we can write that proportion and solve it. So we get 4x is equal to, hold on a second. Let's see. Oopsie. Hang on a second. I am struggling here. Okay, so the rest of this is going to be Um, 4x is equal to 6 times 13. I don't know. 6 times 13 is 78. And then divide by 4. So that means x is equal to 19.5. So this perimeter equals now 19.5, and that would be units. And see, it is bigger than that small shape, but it is directly proportional because their sides are proportional. If you dial the sides bigger, the perimeter will follow. It will become bigger as well. Okay, as long as you got similar figures. So this should be review from a chapter or two ago. But I just wanted to review that with you so that you guys can think about like what we're going to do next. So now we're going to talk about, we've done area since then. So we're going to say, well, what if you have area? Okay. How would the areas change if you made a bigger figure? Okay. Would it just, if you double the sides, would the area double? Would it change it? And the answer is no, because it's up a dimension. Okay. And so here's the rule for this. The rule for the perimeters is they're equal. The ratio of the sides equals the ratio of the perimeters. That's what happens with perimeters because they're both a linear dimension. Just like area is squared, guess what? It is leveled up. Okay, the sides are not equal to the areas. The ratio of the sides is not equal to the areas. And so what we're going to do is we're going to say, if you write the ratio of the sides, you have to amp them up a dimension. Okay. And you need to be able to say, we can write the ratio of the sides, but sides doesn't equal area. You got to square the sides, and then you can set them equal to the ratio of the areas. And so, so take the ratio of the sides. It doesn't equal the areas because the areas are squared. Okay, and so they're not going to be equal. So you have to take the ratio of the sides, square those, the top and the bottom, and now you can set them equal to the areas. Okay. Sometimes I talk about like an analogy of like Spy Kids where like people like or the Matrix where people get into like those robot costumes to be like so they're fighting against like the aliens or something like that. So they're little people, but they have to level up and wear like this big, huge like machine costume so that they can fight against, whatever else they're trying to fight. Okay. And so they're not equal. It's like a kindergartner fighting a high schooler and be like, let's wrestle, you'll be fine. You're like, no, you need to grow it up so that they can level out and actually be an equal to the opposing force. And so area is squared. And so therefore the side length is not. So to be able to make them equal, you have to take the ratio of the side lengths, square them so they can equal out the area. And so perimeters and sides, those are fine. Those can be equal. Those proportions are the same. So if you want to show this, you're like, okay, we could do the ratio of two sides here. So just pick two sides, 8/12. And then you could do the ratio of the areas. And so the area of the small one is going to be 1/2 times base times height. So you do 1/2. If you got a right triangle, just do the legs. So you do 1/2 times 6 times 8. So that would be 24. And then the area of the bigger one, it'd be 1/2 times 9 times 12. That would be 54. Okay. And so if you write the ratio of the areas as it is, guess what? If you divide, let me see if I can get this on my calculator. If I just did 8 divided by 12, let's see, does that actually equal 24 divided by 54? No. Okay, these are not equal, are they? But if you want to level it up, okay, so that you can equal your opposing force, you've got to square up those sides. So if you do 8 squared over 12 squared, that's going to be 64 over 144. Now, guess what? If I divide 64 by 54, no, 64 divided by 144. Guess what? Now it equals this right here. Both of those are 0.444. So the ratio of the sides doesn't equal the ratio of the areas. Well, the ratios of the sides squared does. Okay, so that's what we're going to be doing today. Okay, so perimeters are equal to sides. That's completely fine. So on this one, they're going to be like, okay, can we do this? And the answer is, of course we can. We want to find the area of this one right here. Okay, so it's pretty straightforward to be like, I see two sides that correspond. They're similar. Okay. And so what would be the ratio? What would be the area of this other figure? Okay, and so here we go. Let's take the ratio of the corresponding sides. And as long as you're consistent, it's fine. So I'm going to do the big and then the small. You could do small or big as long as you stay consistent. So the ratio of the sides is 8/5. And the thing is, does that equal the area? So the sides, and then we got areas. The areas is the big one is 32. We don't know the small one. Are those equal? No. To make them equal, again, you got to level up the linear dimension to make it squared. So if you square the top and bottom of this, it will equal the ratio of the areas. And so let's do this. Let's go up here and we're like, okay, if you get 64/25, I just squared 8 and 5, equals 32 over x. We can cross multiply, you get 64x equals 25 times 32, that's 800. And then I divide by 64, so x is equal to 12.5, and that would be centimeters squared. So that means this smaller area is 12.5 centimeters squared. How'd I get it? Well, if I know they're similar, they're going to be related, they're going to be proportional, but you have to make sure they're leveled up to be the same. Okay. If you're comparing areas with side lengths, there's going to be a squaring differential. Okay. So the ratio of the corresponding sides is 6/8. Okay. That's small and then big. These are sides. So to make them equal the areas, the ratio of the areas, I got to take the sides and square both at top and bottom. And that will give me the appropriate leveled up division. Again, a kindergartner should not wrestle against a high schooler, should he? No. So you got to level it, let them grow up, and then they could even out. Okay. And how you grow it up is you square the ratio of the sides. So you get 36/64 equals 13.5 over x. We're going to cross multiply. And you're going to get 64 times 13.5 is 864 equals 36x divided by 36. X is equal to 24. That means this is 24 feet squared. And it should make sense. Do you see how it is bigger than the smaller shapes area? Okay, so that's how you do it. And then got two more left. The next one is interesting, and this one does have a friend in your test, so don't tune me out. Notice they don't give you this side, do they? The ratio of the sides, so x/6 equals, those are the sides, equals the ratio of the areas, 50/72. But are they really equal? No, you have to square the sides for them to be able to level against them, okay? If it was just sides and perimeter, they'd be equal. But sides and area, you got to square the sides so they can keep up, okay? And so what we're going to do is we're going to square x. Oh, that's hard. Square 6. Okay, so this is a good one. I believe you're going to do one of these and one of these on your test. And so then we'll cross multiply. You get 72x squared equals 50 times 36 is 1800. We've done this before. Divide both sides by 72. You get x squared is equal to 25. It is decimally on your homework. Take the square root of both sides. You get x is equal to 5. So that means the side is 5 inches. And it should make sense in the picture. Yeah, it's smaller than the other related side. Okay. If you get a decimal on your homework, that's fine. This last one's kind of tricky. I don't believe it has any friends on your test. But you probably have to do it on your homework a little bit. It says if the perimeters of these, that's a linear dimension. If the ratio of the perimeters is 66 to x, okay, those are the sides. And if that equals the ratio of the areas. Now, perimeter is linear and the area is squared. So that's 252/28. You have to square the linear dimension, whether it's perimeter or side. So this is a little weird, okay? And so if you solve this, you're going to get 66 squared is 4356 over x squared, okay? Equals 252/28. If we cross multiply, we're going to get 252x squared equals 121,968. Not a space. 121,968. That's a big number. Divide both sides by 252. You get x squared is equal to 489. Square root it, you get x is equal to 22. So that means this perimeter is 22 millimeters. I have to put 3 m's, so that's kind of silly. So the ratio of sides doesn't equal the ratio of the area. Okay, the ratio of the sides or perimeter squared does equal the area. So if you're trying to write a proportion from side lengths or perimeters, then you're going to have to square that fraction so that can level up and equal out the area. All right, well, thank you so much. I hope you guys have a great day.